See this one, beta. So what is the last part we have started? Angular acceleration represented by your alpha. So what is an angular acceleration? I told you, rate of change of angular velocity. Rate of change of your angular velocity is called as of your angular acceleration. Exactly similar to your linear acceleration, beta. A is equals to dv by dt. Here it is alpha is equals to d omega by dt. As we are writing in the differentiation, so it is known as what? Instantaneous acceleration. If I am writing average acceleration, beta, alpha average is equals to delta omega by delta t, that is equals to omega 2 minus omega 1 divided by t2 minus of your t1. Unit is what, beta? Radian per second divided by second. So it is radian per second square.
Yes.
Okay, na?
Yes.
T is equals 0, omega is represented by omega naught, which is known as initial angular velocity. And T is equals to T, omega is represented by omega, that is known as of your angular velocity after certain interval of your time. Okay, na?
Yes, sir.
Yeah. So alpha will be equal to your omega final minus omega initial, that is omega naught, divided by T final minus T initial. That means omega minus omega naught divided by T. So ultimately what I'm getting alpha. So alpha is equals to your omega minus omega naught
Omega
divided
naught
by T.
t.
So if I take this T here, this is omega minus omega naught is equals to alpha into T minus omega naught I'm taking on this side. So omega is equal to omega naught plus alpha into T. This is exactly similar to V is equal to U plus of
U
your
plus
AT.
at.
So A is here in the circular motion represented by alpha. V in the circular motion is represented by omega. And
Omega.
U in circular motion is represented by your
Omega.
omega naught. So it is valid only when acceleration is constant. That means angular acceleration is remaining for me constant part of relation. The same way, alpha is equals to d omega by dt. By integration, the calculus method also will give the same relation. Integral of your d omega is equals to integral of alpha into dt. Or omega, if I'm integrating from initial to final, initial is omega naught, final is omega. Alpha is a constant, bring out. So integral of dt is nothing but t. Substituting upper limit minus lower limit, t2 minus t1. T2 is t, t1 is 0. So it is alpha into t2 minus t1. T1 value, if I'm taking 0 here, it is alpha into t. Substituting the limits here also, omega minus omega naught. So I'm getting omega is equals to omega naught plus alpha into t. And one more point I told you, area under alpha in t always gives me what, beta? Change in angular velocity. Change in your angular velocity. Area under your alpha in t will always gives me what? Change in angular velocity particulation. The same way, what are the remaining kinematic equations, beta? I can write here kinematic relations for circular motion. For circular motion. So what are they, beta? First one, omega is equals to omega naught plus alpha into t. Second one is s is equals to ut plus half a t square ki s is represented by theta, v is represented by omega, a is represented by alpha, u is represented by omega naught. So s is in the place of theta, u into t means right now omega naught into t plus this one is half into a. A is nothing but here how much? Alpha into square. Okay. And one more equation is v square minus u square is equal to 2s. V means omega, so it is omega square is equals to your omega naught
Omega
is
naught.
plus 2 alpha into theta. 2a into
Yes, sir.
s. Okay. Then fourth one is nothing but of your nth formula. That means theta nth will be equal to your omega naught plus u plus half of your a into t square. So this
Yes.
one is half into alpha into your 2n minus 1.
T square. Yes, sir.
Isn't it? So these are the basic equations which you need to remember. So let us try to do one problem based on this one. Say for example, we got angular displacement. We got angular displacement of particle. Angular displacement of particle in circular motion. In circular motion varies with time. T as theta is equals to t cube minus of your 2t square plus of your 3. Then find number 1 angular velocity. Then find your angular velocity at t is equals to 2 seconds. Second question, angular velocity in first 2 seconds. And the third question is angular acceleration at t is equals to 2 seconds. And fourth one is angular acceleration in first 2 seconds. Okay. Let's see the question once again. We have got an angular displacement of the particle in the circular motion, which is varying with the time as theta is equals to t cube minus 2t square plus 3. Find the angular velocity at t is equals to 2 seconds. Chop answer and
2, 4, 8, 8, 9, 8, 9, 6, 0. Sir, 3, sir. Theta is here. If theta is equal to 3, first one.
Angular velocity is asked, na? Omega, na?
Yes,
Omega
sir.
is equals to d theta by your dt, na?
Yes, sir.
So omega is equals to d differentiation of theta. Theta value in this t cube minus this one is a t cube minus of 2t square plus 3 plus of your 3 divided by your dt. So omega is equals to differentiation of t cube is how much beta? This t is t cube small t. This one is t kabatti. So this one is nothing but differentiation of t cube is nothing but 3 into t square minus 2 is out. Differentiation of t square is nothing but of your 2t. Differentiation of 3 is nothing but 0. So omega is equals to how much for me? 3t square minus 4 into t. At t is equals to 2 seconds is awesome. At t is equals to 2 seconds. Omega value will be equal to how much better? 3 into this one is a 2 square minus 4 into a 2. This is a 3. 2 square is nothing but 4 minus 8. 3 4 is 12 minus 8. So 12 minus 8 is 4 meter per second. Achinda?
Yes, sir.
Isn't it? Second one, what is asking right now? Is
Sir, 1
asking
minute,
the
sir.
angular velocity in the first 2 seconds. That means average. Isn't it?
Yes, sir.
Second one is nothing but of your average particulation now. So if I'm talking about
Sir,
average,
Okkasari, can you show the previous page, sir? I just found.
yeah.
Okay, sir. Yes, sir.
Okay. What is asking beta? Average. So average is equals to what beta? Delta theta divided by delta.
Delta T.
That means theta at t is equals to 2 seconds minus theta at t is equals to 0 seconds divided by your 2 minus of 0. So average angular velocity is equals to theta at 2 seconds. That means in the place of theta, you keep here 2 in the place of t. That means this will become for me how much beta? 2 cube. So this will be equal to your 2 cube minus this one is 2 into this one is of your 2 square plus of your 3 minus in the same way here it is a theta, that is nothing but of your in the place of this one 0 cube minus 2 into 0, this one will come only for me 3 divided by 2 minus 0. Achinde point?
Yes, sir.
Isn't it? So theta 2 ante in the place of theta, in this place of theta, this one is 2 cube minus 2 into 2 square plus 3. Then 0 is 0 cube minus 2 into 0 square plus 3. So that value I
Yes.
have written here divided by
Yes,
2
sir.
minus 0. So how much I'm getting, you see?
8 minus 8. Sir, 3, sir. 3 minus 3 is 0 only.
Antena?
Yes, sir.
So average will become how much for or in the first 2 seconds will be equal to how much for me? 0.
0.
Clear? Huh?
Yes, sir.
Sure. Next question, Judo sir. Angular acceleration. Angular acceleration at t is equals to 2 seconds. How to write the angular acceleration beta? Alpha. Alpha
sir.
is equals to d omega by your dt. So that is equals to d. Omega value is nothing but t cube minus of your 2t square plus of your 3 divided by your dt. That means this alpha will be equal to differentiation of t cube is how much beta?
3 square
3 into t square
minus 2. Sir, so like 2, you have to keep it onto a side only, sir. You have to do 2 into.
differentiation of t cube is nothing but how much for me? 3 into t square
Yes, sir.
minus
3
this
into.
one is nothing but of your 2
Yeah, that's
into
okay.
this one is also
2.
equal to how much for me?
2t. T, sir.
2t.
Yes.
Ante kada?
Yes, sir.
Difference of t square is nothing but 2t.
2t. Yes,
The next one is nothing but of your
0, sir.
0. అంటే
D
డైరెక్ట్లీ ఐ
into
కెన్ రైట్
df
డి
to
ఒమేగా బై డిటి ఇప్పుడు వచ్చింది కదా మనకు. సో
yes,
డి
sir.
ఒమేగా బై డిటి రాలేదు కదా. ఒమేగా వాల్యూ ఎంత ఇచ్చా? టీటా కదా మనకి ఇచ్చింది టీటా. దట్ మీన్స్ ఐ నీడ్ టు రైట్ దిస్ వాల్యూ. సారీ, దిస్ ఇస్ ద
Yes,
వాల్యూ ఆఫ్
sir.
ఒమేగా
Omega.
కదా,
Yes, sir.
because it
3t
is
square minus.
omega part of relation. So sorry, here in this one
Okay, yeah, we have to write 3t square minus 4t.
అంతే కదా, because it is omega
Yes,
na
sir.
beta.
Yes, sir. Yes,
So
sir.
omega means this one 3t square minus 4t. So it is ఎంత
3t square minus
square minus
4t.
4t. This one is 4 into t. So this
Yes.
is 3 out. Differentiation of t square is how much beta?
T.
2t minus
Okay,
4.
yeah, 2
Differentiation
into,
of
yes,
dt by dt is nothing but 1. That means
yes,
alpha will become how much for me? 6 into t minus
yes,
4.
4.
So at what time is asking? At t is equals to 2 seconds. That means alpha is equals to 6 into 2 minus 4.
8, sir.
So this will become for me how much?
8
8 radians per second.
seconds.
Okay, na?
Yes.
Now can you do the fourth one beta? So what is the fourth one is asking? Angular acceleration. Angular acceleration first 2 seconds. That means same like this. Alpha average value is equals to how much for me? Delta omega by delta t. అంతే కదా.
Yes, sir.
So delta omega means right now what? Omega at your t is equals to 2 seconds minus omega at your t is equals to 0
0.
divided by your 2 minus
2
of your
minus
0. అవునా కదా. So
Yes,
omega
sir.
t is equals to 2 seconds means in the place of your omega, ఇది omega కాబట్టి. So this will become for me how much for me? 3 into your, this one is
T
nothing but
square.
2 square
Okay.
minus 4 into your, this one is nothing
Okay,
but 2.
sir. So latest value of omega we have to put.
Is better? Yeah, in the place of omega, this value.
So like whichever. Yes, sir. So if you are putting that, means directly you are writing, sir.
Yeah, or direct omega only, na beta.
Yes, sir.
Because it is not d kada if to differentiate.
Yes, sir. Yes, sir. Got it, sir.
So omega value directly 3 into
Yes.
2 square minus 4 into 2 minus your,
Yes.
this one is omega, everything is 0. So this will become
0.
for me 0. అంతే కదా. 3 into
Yes,
0
sir.
minus 4 into 0
Yes.
divided by 2. So this will become how much for me, Judo?
4, 3, 12.
3 into 2 square is nothing but 4 minus 4 to the 8 divided by
12 minus 8 by 2.
12 minus 8 divided by 2.
2,
How
sir.
much? 4 by 2. And that will be equal to 2 radians per your seconds.
Second.
Chinda,
Yes.
isn't it? So that was about your given conditions, right? Okay.
Yes.
Keep a note beta. See, if angular acceleration, if alpha value is becoming 0 beta, that means omega will become for me constant. అంతే కదా. If acceleration is 0, angular velocity is constant. That means magnitude of the velocity will be equal to your constant. If magnitude of the velocity is constant means differentiation of your dv by your dt will be equal to 0. అంటే acceleration will be equal to 0. If acceleration is 0 but the body is moving at a constant velocity, then the body is said to be, then the body is said to be in uniform circular motion. And the body is said to be in uniform circular motion. ఇదంతా నీకు చెప్పినట్లు ఉన్నా నేను
లేదు సార్,
చెప్పలేదా?
లేదు సార్.
If alpha value is 0 beta, isn't it? If angular acceleration is 0, then omega will become for me constant. Like in kinematics, if v is equals to constant, then dv by dt is nothing but what beta? Acceleration is 0. Then the body is said to be what? Uniform circular motion. So when the body will be uniform circular motion beta? If alpha is 0 or
Zero.
omega is for me constant, or omega is equals to your constant part of relation. So I can say that in uniform circular motion, in uniform circular motion, in uniform circular motion, very important point with this. Uniform circular motion, tangential acceleration is 0 and radial acceleration is not equal to 0. So net acceleration will be equal to your radial acceleration. That means when a particle is moving in a circular path like this, okay, generally the particle has two velocities. Okademo, this one is nothing but radius, and this one is along this one. So ఈ tangent లో ఉండేదానికి tangential acceleration అంటాం, towards center లో ఉండేదానికి మనం radial acceleration అంటాం, and the resultant of this one will be acting in this direction. So this is nothing but of your a net. Okay na? So in uniform circular motion, tangential acceleration ఎంత అవుతుంది? 0. So this is your uniform circular motion, but radial acceleration is not equal to 0. So that is the reason a net is equal to your AR. Actually, a net ఎలా calculate చేస్తున్నాను? ఈ రెండింటి మధ్య యాంగిల్ ఎంత? 90. Parallelogram law of vector addition is చేస్తాము. A net is equals to under root of your, this one is of your a1 square plus of your a2 square plus 2 times of a1 a2 into your cos 90. Cos
Yes,
90 కాబట్టి ఇది మొత్తం 0 అయిపోతుంది. So a net is equals to under root of a1 is equals to how much for me beta? A tangential square plus of your a radial square. Tangential square 0 అయిపోయింది కాబట్టి keeping that value I am getting this value.
Sir,
Okay na?
actually, this part you said, sir.
I told you, no?
Yes, sir.
Yeah. Chalo. The same way in non-uniform circular motion. Next one. In non-uniform circular motion. In non-uniform circular motion, both the radial acceleration, both radial acceleration is not equal to 0 and tangential acceleration is also not equal to 0. That means net acceleration makes an angle theta, isn't it? But theta is not equal to 90 degrees with velocity v bar. So చూడు దీంట్లో ఏమవుతుందంటే, so this is your circular path. Now here at the center you have one acceleration that is known as of your centripetal acceleration, and along in this direction we have the tangential acceleration. Velocity is also in the same direction. Okay, an angle between them is right now 90 degrees, but resultant is making an angle here right now like this. So this is making your a net, and a net makes an angle with the vertical. So this one is your theta. Very important another. Okay na? So net acceleration will be equal to how much beta? Net acceleration makes an angle theta with your v bar or tangential acceleration, we can say v bar or your at, isn't it? Now how do you write the value of tan beta? So tan theta is equals to your a radial divided by your a tangential. AC ni manam a radial kuda anachchu. Okay na? So
Yes.
tan theta is equals to a radial is nothing but of your how much for me or beta? Can anyone tell me? Radial acceleration will be equal to your how much, and tangential acceleration will be equal to your how much for the given condition. Radial acceleration చెప్పేలా రాయొచ్చునా? How do you write the radial acceleration and how do you write the tangential acceleration? నేను ఆల్రెడీ ఇది కూడా చెప్పాను బేసికల్ చాలా సార్లు. So radial acceleration is represented by your AR. So I'll write here, see, radial acceleration is AR is equals to R into your omega square. Okay. Or else R relation between relative velocity and omega is V is equals to R omega. V is equals to R omega. So omega is equals to, I can write as V square by your R square. This one will get cancelled. So it is V square by your R. So radial acceleration is equals to V square divided by R divided by tangential acceleration. Tangential acceleration is represented by your AT. AT is equals to how much beta? AT is equals to your dV by your dt. That is equals to d in the place of V. If I write R into your omega by your dt. In this one, radius is constant, so bring out d omega by your dt. So that is equals to R. D omega by dt is what beta? Alpha. So this will become for me your R into your alpha. So this one is R into your alpha. So that means ultimately I can write tan theta value is equal to how much beta? Tan theta is equal to, tan theta is equals to, this one is V square divided by R will come down. So it is your R square into alpha. Now what is V square by your R square? I can write as beta omega square and raskocha. So tan
Yes,
theta is equals to, because from this one is omega is equals to V by R.
yes.
Kada. So V square by R square means omega square divided by your alpha. Itla kuda raskocha. So this is the value of your tan theta. Or else I can write here theta is equals to your, theta is equals to, I can write here tan inverse of your omega square by your alpha part of the equation. Okay, na?
Yes.
So these are some of the formulas which you need to remember in the uniform circular motion. So in the non-uniform circular motion, both radial acceleration and tangential acceleration is zero. Whereas in the uniform
Not zero.
acceleration, tangential acceleration will be zero. Tangential acceleration will be equal to radial acceleration is not equal to zero
Zero.
part of relation. So that is the reason we are getting A net is equal to how much for me beta? AR part of relation. Whereas in the non-uniform circular motion, radial acceleration and both the tangential acceleration not equal to zero. So we can be getting the value of your tan theta is equal to AR by your AT. Simplifying it, we got this relation. And how do you get the resultant beta? So we can get the A net by the formula. A net is equals to under root of your radial acceleration AR square plus of your AT square, isn't it? So that means A net is equals to AR is equals to how much beta? AR is equals to I can write R into your omega square. So it is R into your omega square and this is whole square plus tangential acceleration. AT is equal to how much for me? R into your alpha. So this one is your R into your alpha whole square. It means this can be written as under root of your, this one is R square into omega to the power of 4 plus R square into alpha square. So I can bring the R out. So it is under root of your omega to the power of 4 plus of your alpha square. So this is your A net. So this is your A net part of relation. Okay. Then in the same way, omega value is equals to how much beta? As omega is equals to 2 pi by capital T, and that is equals to 2 pi into your frequency. So net acceleration also I can write as A net is equals to R under root of your omega value will be equal to how much beta? 2 pi into your F wholes to the power of 4 plus of your, this one is of your alpha square. ఇట్లా కూడా రాసుకోవచ్చు. Okay,
Yes.
na?
Yes.
So these are the different forms in which you can write the value of your A net. Frequency ఇచ్చినప్పుడు ఇది రాసుకోవాలా, టైం పీరియడ్ పెట్టినప్పుడు ఇది రాసేసుకో. Net
Yes.
acceleration is equals to for the non-uniform circular motion is this one by using the formula A net is equals to under root of your ET square plus of your AR square part of relation. Clear, Anna?
Yes. Sir.
So this one video. For a particle moving in a circle of radius, say for example some 5 meters, or say for example 50 meters, with V is equals to 40, with V is equals to how much for me? 40. Then find its tangential, comma, radial, comma, net acceleration at t is equals to, let's say for example, some 3 seconds, or maybe 1 second or 2 seconds, anything is. So now what is the condition right now? For a particle is moving in a circle of radius. Radius is given for me, r is equals to 50 meters. Velocity is given for me 4 and as a function of t. Then find the tangential acceleration kavala. We need to calculate your tangential, we need to calculate the radial, and we need to calculate the net acceleration. So let us try to go for radial acceleration. Radial acceleration is equals to v square by your r. V is equals to how much beta? 4 into t. This one is nothing but whole square divided by your r. So that is nothing but 4 into t is equals to how much beta? T value is given how much for me at what time? 3 seconds. This one is nothing but of your 3. And this one is nothing but whole square divided by radius is nothing but 50. Until then, a radial will be equal to 4 into 3 square is 9. 4 in 4 square. So this is 4 square. 4 is the
4 into 3, first 4 into 3, 12, sir. 12 into 12 square, 144.
okay, 144 divided by 50. And that will become for me 7 to 7 and 7
72
to
by
divided by
25.
25. So
Yes.
this will be meter per second. We can do if we need some more calculation for that. Okay, this one is for your radial acceleration. This is second one. First one is the tangential acceleration. Tangential acceleration means what beta 80. So 80 is equals to your dv by dt. So
Yes,
velocity as a function of time is given for me beta, isn't it? So this one
yes,
is
sir.
a d. Velocity is given how much for me? 4 into
4
t divided by your dt. So 4
Yes,
is
sir.
out. This one is dt by your dt. This one gets cancelled. So the answer is how much for me? 4
4.
meter per second square. And the last one is nothing but how much beta? Third one. You do the calculation of this one. I'm just leaving it for you. A net is equals to under root of your a tangential square plus of your a radial square. Under root
Yes,
of your tangential is how much for me? 4 square. That is
4
nothing but of your 16.
16.
Plus this one is nothing but of your how much? 72 divided by this one is 72 divided by 25 whole square. You get a big term. You can do that calculation later and just see the method how I have done that. Is it clear?
Okay. Yes, sir.
Isn't it? So I hope you got this idea how to do such type of equations in your accelerations part of relations. Okay, na? చలో. ఈ క్యాలిక్యులేషన్ నువ్వు చేసుకుంటావు కదా, ప్రాబ్లం లేదు కదా. 72 divided by 25
Yes, sir. Yes,
approximate
sir.
తీసుకొని
Yes.
calculate చేస్తాం.
Yes.
ఓకేనా? How much time is there, beta? Still, I think it will be
10
getting
10 minutes is there, sir. 9 minutes is there.
okay. Chalo. Next one, Kunal. Centripetal force. Centripetal force. Yesterday's second part we have not recorded actually.
Actually, because it failed like first time, sir, we were in a hurry.
Yeah.
I forgot to.
Chalo. Centripetal force. So what is the centripetal force, beta? School lo chadive untavu kada. The force required for any body to move in the circular path. Any particle in the universe which is moving in the circular path or arc of a circle or a small part of a circle also, then the force required is called as a what? Centripetal force. So I can say here right now, the force required for a body, the force required for a body to move in circular path, to move in your circular path and is directed towards the center is called centripetal force. Is called what? Centripetal force. Okay, so that was about your centripetal force. What is the centripetal force, beta? The force required for a body to move in a circular path, and it is directed always towards what, beta? Center is called as of your centripetal force. Now see here, this force has a tendency to, this force causes centripetal or this force is your cos of centripetal, or you can say your radial acceleration. So centripetal acceleration or radial acceleration is because of your centripetal force. So hence, what is the force I can write, beta? Centripetal force is equals to, hence centripetal force F is equals to M into your centripetal acceleration, AC. So it is equals to M into AC is how much for me? V square by your R. So F centripetal force is equals to M into V square by R, or that is equals to M into V is equals to R square omega square divided by R. So this one gets cancelled. So it is M into R into your omega. R centripetal force is also equal to your M into V into your omega, because R into omega can be written as of what, beta? M into V is equals to R into your omega. Ante kada?
Yes.
So I can write here R into your omega part of relation. So this one is how much for V? This is omega square kada, of omega square. So it is half is equals to V is equals to R into 1 omega. If I'm taking here, it will be V and 1 omega will be left. So FC is also equal to your MV into your omega part of the relation. So these are the different forms of your centripetal force. This is FC is equal to MV square by R, or FC is also equal to your MR into your omega square part of the relation. Okay, na?
Yes.
See better. This force can be provided by, this force can be provided by, number one, it may be by tension. Number two, maybe by friction. Friction may also provide you centripetal force, and maybe your field. Field ante, it can be your magnetic.
Okay.
It can be magnetic, or it can be your electric.
Electric.
Second year loss. So it can be because of the magnetic field, or it can be due to your electric field part of relation. In the same way, it can also be maybe due to normal force. Maybe due to normal force. This all forces can produce the centripetal forces, beta. So centripetal force is being created by, centripetal force can be provided by what, beta? Either by your tension, either by your friction, either by your field, if I can say, or by your normal force, part of relation. Okay, na?
Yes.
So that was about your centripetal force. So centripetal force is nothing but what, beta? The force required for a body to move in a circular path, and it is directed towards the center, is called as of a centripetal force. This force is the cause, which is the cause for your centripetal or radial acceleration. This is the cause for your centripetal or your radial acceleration. Now, what is the force formula? F is equals to M into AC from Newton's second law. AC is equals to V square by R. ఇంతకు ముందు వచ్చింది కదా, radial acceleration చూడు ఇక్కడ రాశాను నేను. AC is equals to how much we are written right now here? Tangential acceleration is 0. Then here in the non-uniform acceleration, AC. చూడు, A radial అనుకున్న ఒకటే, AC అన్న కూడా ఒకటే అనుకుంటా.
Yes,
AC or AR. There is how much for me? V square by your R. V square by R. That value has substituted here and simplified for the given condition. So it is in the place of this one, V square by R. So FC is equals to V square by R, or V is equals to how much, beta? As V is equals to R omega. So in the place of V, I have written here R into omega square kabatti R square omega square divided by R. So దీంట్లో square ఈ R వెళ్ళిపోయింది, MR into your omega square.
Omega
So
square.
from here I can write this one as, this can also be written as M into R omega into omega I can write. So R
Yes.
omega is nothing but V. So it is your MV into your omega
Yes,
part of
sir.
it. Is it clear?
Yes, sir.
How much time is left out, beta?
2 minutes 30 seconds.
So let's stop it. Hello?
Yes, sir.
I'll stop and rejoin, beta.
Okay, sir.